Okay, so good afternoon, everyone. In the last session, we have discussed about the clustering in non-Euclidean space, as well as we have covered the topic frequent pattern-based clustering method and clustering high-dimensional data. So basically, we have given our we have done the discussion on the clustering. Now, the last topic from the fourth unit is clustering for streams and parallelism. So as you are aware about the data stream is a form data which is generated in the form as stream, and there are parallelism while generating the data. So when we perform the clustering, we want to group the similar kind of object within a same cluster, then we have to perform the clustering for a stream and parallelism. So it is quite same as we'll perform the clustering for uh, normal big data point or non-stream data points. Here, slightly bit different. We have already covered various algorithm, which is related to the data stream. So, data stream clustering is defined as the clustering of data that arrive quickly, such as telephone record, multimedia data, and financial transaction. So, suppose you want to find out that what is the telephone record related to a particular duration. So you can cluster all the information that is generating at a particular duration. Or you can generate all the information which is of a certain uh, uh, duration, certain time. You can also perform the data stream clustering on multimedia data. So you can cluster the video information. You can define categories of the different video information, then different audio information. Basically, we'll study the streaming algorithm, and we for a given sequence of point, we construct a good clustering for this stream. So for this, we'll go through this Wikipedia article, which will give us a better point about the data stream clustering. So in computer science, data stream clustering is basically clustering of data that arrive continuously. So whatever the data is generated with the data stream application, that can be used as an input for the clustering. Basically, we'll study about the streaming algorithm, and the objective of these streaming algorithm is that for a given sequence of point, they will construct the clusters for a small amount of memory time. So that is a one constraint. So you can define the problem of data stream clustering as such as input a sequence of endpoint in metric space and integer k, and you can output the k center in the set of endpoint. So basically, we'll initially we define the integer value k, and we'll take k as a number of cluster centers, and based on that centers, we can take the endpoint and minimize the sum of distances from data point to their closest cluster center. The same rule that can you apply in a different clustering algorithm can also be applied here. So the most common algorithm is a stream. It is given by the Guha, Misra, and Motovani, Okargan. It will achieve a constant factor approximation for the k-median problem in the single passing using a small space. So we have already covered the single pass algorithm. Single pass algorithms are those algorithms which take a one pass or two pass to find out some information. So if you define the theorem for the stream, it can be as such. Stream can solve the k-median problem on a data point stream in a single pass with the time and space complexity up to factor of this, where n is the number of points and e is less than 1 by 2. So I will not go in detail about the stream. I will give you it as an assignment and trying to go through this article and find out how the stream algorithm will work. And if it is possible, then we'll take a stream algorithm. We'll implement the stream algorithm in our lab session. We'll try to find out some good cluster using the stream algorithm. Now, so that was all for the fourth unit, and we have already discussed some paper. Let me open the syllabus first. Okay. Is syllabus visible to everyone? Is syllabus visible? Is syllabus visible? PDF is visible to everyone? Okay. So in the fourth unit, we have covered the frequent item set and clustering, as well as we have covered the mining frequent item set. So we have gone through some algorithm which is required for the mining frequent item set. We have gone to the market-based modeling algorithm, and basically we have discussed about the a priori algorithm, and we'll take one example how the a priori algorithm will work. We have discussed the problem of large data set in a main memory because we have constraint of the main memory, so how it will able to handle the large amount of data set. And then we discuss about the limited sparse algorithm, and then we have discussed about the clustering technique, hierarchical clustering, k-means clustering, Adams and data. For k-mean clustering, we have discussed some implementation, k-means implementation in the Python. So where we have seen some data set being passed to the k-means clustering algorithm, and we have gone through the code, and we'll find out what will be the output. Then we discuss about the click and proclus algorithm, which is a well-known clustering algorithm. And then we discuss about the frequent pattern-based clustering methods, and then clustering in non-Euclidean space. So basically, when we perform the clustering, we will take the Euclidean space as a distance metric. But if suppose there is a situation where we can't take the Euclidean space as a distance metric, then we can perform the clustering in a non-Euclidean space. It is quite same. There will be slightly change in your algorithm where you will perform the clustering. So we have gone through the how to perform the clustering in non-Euclidean space and what are the constraints of it. And in the today we gone through discuss about the clustering by stream and parallelism. So in this unit we have discussed about the various research article. So I have given the reference in the PDF. And it is also already uploaded on the Moodle. So please go through the research paper and write down a summary of each and every paper, and trying to find out some important point related to the unit 4. So that will be your one of the assignment. Now, if no, is there any problem with the unit 4? If you have any issues, we can discuss it again. Is there any problem with unit 4? What is your view and suggestion? I really appreciate your any suggestion from your side. You can also use the chat box. Okay, so I will assume that is it okay with everyone? If you have any issues with the unit 4 with any topic, then we can again create a new session. We'll discuss about it. And now we'll move towards the unit 4. So we'll talk about the unit 4, unit 5. So unit 5 is basically talk about the frameworks and visualization. So basically whatever the framework is available to process the data set, and how can you analyze the data stream, and how can you visualize in a real time. So basically we'll go through with the Hadoop MapReduce system, and then we discuss about the pig, hive, HBase, MapR, NoSQL database, Hadoop distributed file system visualization. So in this one, I will only cover the Hadoop MapReduce, and rest of Pig Hive I will give you as assignment so that you can write some few point about it. If any student is interested to give any presentation on that on any given point, then I will definitely welcome it. I welcome him or her and to give their overview about the Pig and Hive. Introduction to R. What I will try to do in a lab session, if it is possible, then I can take online uh, lab. We can run the install the R, and we'll take some data set is importing the R, and then we'll perform the some type of descriptive statistics and exploratory data analysis, and with some visualization. And that all for the unit fifth. So I think it's quite through unit fifth is quite depend on your side, because it is more as a practical session. I will give you the overview about these framework, but it will require more practice. So at the end of the unit fifth, I will give you some programs, so you can run those programs to find out, to gain more experience about these framework and the introduction to R. So let us start with the uh, unit fifth. That is a written unit for. So that is a unit fifth. So I want to discuss about the Hadoop MapReduce. So in this today's session, we'll only take a simple overview of the Hadoop MapReduce. In the next upcoming session, we'll take some more about overview about the Hadoop MapReduce. So let me open one more file. One moment. Let me open the file. Okay. So is this file visible to everyone? Is this file visible? What is Hadoop introduction, architecture, ecosystem, and component? Guys, is it visible? You can give your response in the chat box. So I will assume that it is visible to everyone. So if you're not able to view the file with Hadoop architecture and ecosystem, you can respond in the chat box immediately. So what is Hadoop? Basically, Apache Hadoop is an open source software framework. It is used to develop data processing application. So basically, Hadoop is developed to work in the distributed computing environment. So it will require multiple computing system, and it will take some tasks. For example, suppose you want to process some word count example from a given input set. So you can distribute the task to the multiple systems sub level at a time. So what will happen? Suppose a single machine, if the all the tasks will be performed by a single machine, so it will take some time to compute the whole task. But the if the same task is distributed to the multiple systems, so again time completion is quite less compared to the single machine time completion. Sorry for interruption. Application built using Hadoop can be run for a large data set, and they can be distributed called cluster of commodity computers. So basically, commodity computers are those computers that is a voluntary shared by anyone. So basically, Hadoop is also favorable among the developer community, because if you have excess computing resources or memory, you can share with the development community, and they can perform the Hadoop MapReduce application on that. As well as you can also set up your own dedicated systems for the Hadoop MapReduce system, or you can take the help of the cloud-based system. Commodity computers are cheap and widely used and available, and mainly used for achieving greater computation power at low cost. So again, it is beneficial in the terms of the cost and the resources required, because when you are developing in any application, so it is not advisable that in the start of application you should invest a lot of uh, you should invest in a more computing resources or more computing memory. So you can take the help of commodity computers, and whenever you find that your application is quite good, then you can move on your dedicated system and so on. Now, next. Hadoop basically uses the Hadoop distributed file system. So one question here, can you tell me the name of file system which is being used on Windows? What is a file system? What is the name of file system used on Windows? I think all of are aware about the file system being used on Windows OS. Anyone? You can use the chat box. Uh, you anyone not aware about Windows file system? What about the Ubuntu Linux file system? What is a file system? Why should we require different file system for different operating system? Why can't we use the same file system? Am I audible to everyone? Hello? Am I audible? Please answer the question because I need to check that whether you are aware about the file system or not. Savannah, you can unmute and please express your overview, express your view. Ariman, am I audible? Ariman, am I audible? Hers, Muhammad. There are approximately 30 students in the session, but no one is responsive. That's not good. Swiksha, Vineet, anyone? What is file system and why we require a different file system for different operating system? Anyone, please respond, guys. Take the 2 minute time, but I need some answer from your side. Pardon me for some here. I have some cough and cold. Sorry for the interruption. Anyone, please respond. Okay, so please write down this question for the assignment and for the unit fifth. Provide the different file system for OS. Write down summary about those file system and why should we require a different file system. So when we are working with a Hadoop microservice system, we require a distributed file system which is called SDFS or Hadoop distributed file system. So basically, when we are working with a large data set, there are some concerns. First concern is the fault tolerance. So suppose you are processing information on multiple systems and there is some unwanted event happen, and due to that event you lost your data. So that must be avoidable. So SDFS will take care of all these things, and it will distribute the information in a such way that failure of any system will not going to hamper the whole application, as well as it will give you an environment to better perform the processing of the application and better handling of the whole storage of information, which is not being possible for a normal operating a file system for Windows like NTFS or FAT or Ubuntu like EXT. So basically, processing model is based on data locality concept where computation logic is sent to cluster nodes. So basically, we can perform the cluster of computer and we can distribute the different task to the different node, and one node will be act as a master and other node will act as a slave. So master node or master computer will always take care about all the slave nodes, what they are computing, how they are storing the data, and it will be continuously monitoring all the information being processed by the slave node. So basically, you need to learn about the Java. If you are already familiar with the Java programming language, so it's quite good for you to work with the Hadoop MapReduce system, because Hadoop MapReduce system will written in the Java. So you need to learn the Java language to work on the Hadoop MapReduce system. So this is your uh, Hadoop ecosystem. In the bottom of this Hadoop ecosystem, you will find out the file system, which is HDFS, Hadoop Distributed File System. Then you'll find out the MapReduce framework. We'll discuss what is a MapReduce framework in next slide. These are the different framework which is developed using the Hadoop MapReduce system. So these framework are Hive, R Connector, Mahout, Pig, Ozor, and HBase. So you please write down one question for the assignment and find out, go through this different framework and write down one page summary about each and every framework, their advantage, their disadvantage, and their applicability in a big data. Okay. So there are two parts of Hadoop MapReduce system. One is a MapReduce, another one is a map reduce, a mapper, and another region reducer. So Hadoop MapReduce system is a computational model and software framework for writing application. So basically, it is a programming model which will take care of all the tasks which is passed to the Hadoop MapReduce system to perform it more efficiently in a less time with a less resources. So basically, it is capable of processing enormous amount of data in a parallel environment using the large cluster of computing nodes. So basically, all the tasks will be divided to the different cluster of compute. As DFS is take care of the storage part of the Hadoop application, as we have discussed, and MapReduce application consume data from the SDFS. So SDFS and MapReduce will continuously interact into each other. And if you create multiple replica data blocks, it is very much required, because if you will not create a replica of any data blocks, what will happen if certain system fail, then you will lost your all the data. And these replica will be distributed on different computing nodes, so it will overcome the possibility of any data loss. Okay, no, next. Although Hadoop is best known for MapReduce, it is also used for a family of related project. So we have already discussed this project, for example, Hive, Sbase, Mahout, and so on. So you can go through this project, Hadoop related MapReduce project, and find out, write down one brief summary about it. Okay. We'll discuss about the Hadoop architecture in next session. Okay, so that will be all for the today's session. Thank you for joining the session.